Hello, hello, welcome. We're going to start in a couple of minutes. Hello, hello. Welcome to our second State of the Industry on AI for IoT. Just as overall remark, we're not going to cover the AI industry as a whole. We're going to be very focused on AI for IoT and more specifically around how AI is being used at the edge. So we're going to do a little bit initially of update on where the entire AI industry is going, but we are going to be very focused on AI for IoT. My name is Philippe Kailash. I am the CEO of Read-Write Lab. Today I am together with Kailash Suresh. Kailash is one of our research analysts specifically focused on AI for IoT. Kailash, do you want to say a brief word?
Yes, good morning, everybody. Hope your week is off to a great start. And I know you cannot wait for the weekend, but this is going to be one exciting hour. It's been a lot of fun putting this together.
So very quickly for people who don't know us, we are a research analyst firm focused on the Internet of Things. We provide research on our platform called readwritelabs.com. We also provide access to our network of experts and partners through the webinar and through events that we are doing on a yearly basis. We are providing visibility to partners through our newsletters, our landscape, and our webinar. And we're also providing education such as this weekly webinars that we're doing today. The way we work is we have an AI platform that crawl the web around specific industries. We're tracking about tens of thousands of companies now across specifically the IoT economy. And our area of research includes smart humans, smart health, smart homes, collaborative economy, everything that is linked to smart humans, and digital transformation, which is the use of the connected device within the enterprise to change how business processes are being done. More specifically, we have a theme around mobilities and smart city, around customer X, which is how to leverage data from the users created by the device themselves to enhance the customer experience, and then the entire infrastructure that supports those applications that we just talked about. And we do that through our AI platform. We continuously track what's happening in the industry, identifying new terms, identifying new companies. We compare that, we provide that to our experts. and that enables us to provide insights to our community that are both very fresh, probably the most updated in terms of new trends, and also very insightful. And you can access all that information at readwritelabs.com. Now let's very quickly go to give you a quick review of the general AI market landscape, and then we'll go over what's happening right now in terms of just AI and IoT, and what's exciting about it. There is a lot happening, and we're at the very early beginning of a very important revolution that is going to change the infrastructure landscape as well. So this is fairly exciting. So we're going to look at that as well, and then we'll go over the new AI landscapes that we've put together for you that Kailash is going to introduce. So very quickly for the AI as a whole, right? The first thing is if you look at all the projections, they are mind-boggling. Praktica, for instance, show a 10x growth between 2019 and 2025. This is one of the faster adoption curve by any market we've seen so far. It's as fast as iPhone or VCR, all the consumer, the adoption of consumer technology, and it's not the case usually for businesses. And the impact is also tremendous. So McKinsey predicts that more than 1.2% of GDP is going to be added per year over the next 10 years due to AI implementation. So it's a major impact, and the market is maturing and now has evolved beyond early adoption on many use cases. AI implementation has grown more than 37% in the past year alone, 270% over the last 4 years. And the market's estimate is today around 7 billion. The other thing that people should know is not that the technology is now demystified. People have moved away from general AI, which basically was planning to take over complex tasks away from humans, and are now focused on more feasible implementation where AI supports humans like an assistant, if you will. The major identified opportunities are in two areas. One is AI augmented work, and the other is decision science. And the reason for optimism is validated by Gartner as well. So if you look at Gartner did a CIO survey in 2019, and one of the things that is very telling is the fact that if you look at the amount of interest by CIO for AI machine learning, it's 2.5x more than the cloud itself. So you have 2.5 more CIOs that believe that AI will be a game changer than cloud will be a game changer. So that's how important that movement is. And just to give you a frame of reference, the cloud computing market is today a $300 billion industry. So think about it this way, right? So AI is perceived as a more important game changer than cloud by a lot of people, by 2.5 more people. So think about what that means in terms of the size of the market at the end. If you look at the other interesting things is, if you look at the Internet of Things, interest. It's also pretty strong, right? It's at the same level as the cloud and mobile, and blockchain, which is another area that we believe is going to be a big important piece of infrastructure for anything that is happening at the edge. Blockchain is going to be a key place of interest as well. Now, if you look at the use case, the use case now has gone beyond fraud detection, which was where AI was playing for the last 20 years, and is now emerging as a force to reckon with in consumer experience overall. So, you have technologies like chatbots, which is now the first level of the first application in terms of application use. You're also looking at call center virtual customer assistance, which is the number 6. Sentiment analysis is also something that people are spending time on, and then market consumer segmentation, which is also something that people are spending time on. The second driver of adoption is everything around digital transformation. So process optimization, computer-aided diagnostics, resume screening, and as you can see, the AI adoption is happening across the enterprise through digital transformation with a particular emphasis on customer experience. The few important trends to note in terms of AI infrastructure in 2019 is twofold. One is the emergence of a hybrid approach. So it's not just cloud; it's a hybrid approach that includes private cloud, public cloud, and on-premise. The move to cloud is still going strongly for anything that is big data. Data cloud providers are growing 50% of more and more, but the cost of cloud services is now starting to be an issue, and companies are looking to a hybrid approach involving public cloud, private cloud, and on-premise to balance cost. Microsoft seems to be benefiting the most from this trend. They are growing the fastest, more than 73%, compared to pure cloud service providers like Amazon, who are growing 50%. Note that Amazon is also reacting and adjusting to this hybrid approach through their AWS outpost. The second trend that is also very important is the emergence of Kubernetes. Kubernetes is emerging as a very strong contender in the containerization space. It is an open source project from Google that was open source since 2014. The major player in the space, Red Hat, has just been acquired by IBM for $34 billion. So it's a big acquisition. And Kubernetes is now being used in AI with Kubeflow. There is also the open source project from Intel called Nota. So you can use Kubernetes to train and scale models built on a framework like the traditional framework like PyTorch and TensorFlow without having to be an infrastructure expert. And then the two other pointers for the AI as a whole is the emergence as snowflakes as a next generation data warehouse, and then the applicability of a serverless approach to machine learning with companies like Algorithmia and Iguazio. Moving forward now for back in June we had the first our first AI for IoT landscape, and we of course, right, the key technologies for AI for IoTs are around data, right? So intelligence, data analytic, around vision, around text, and around audio. And those technologies are being used in the following use case. The first one is access management. today artificial intelligence is powering many identity solutions by learning from millions of transactions and documents to spot anomalies. It's, of course, a very important tool to help combat fraud. Basically now industry leaders want to monitor computer session to identify who is conducting a transaction, if the session is abnormal or the result of a breach. So people should be able to quickly understand based on what the user is doing if the user is human or not. And the other interesting point there is rather than checking against credentials, AI could use a combination of biometrics and user behavior to figure out whether the person can pose a risk to security. So AI is gonna drive all those evolution. They are going to understand the identity of the users, their habits, and so it's a fairly exciting space to be looking into. The second one is, of course, telemetry. Telemetry is very basic measuring and transmitting data from sensors located in automobiles, smart meters, power sources, robots, wildlife, wearables, bed, wherever that data is being created and located. That's typical of what we track here in terms of Internet of Things. Of course, autonomous vehicle, autonomous machines are machines that are capable of sensing their environment and moving with little to no human input. Here, the issue is the path to this ultimate outcome. For autonomous vehicle, there is an SAE classification which goes from 0 to 5, no automation to full automation, and right now we are at level 2. So we are still very early in that path, and we are looking more at AI-driven, as AI assistant driving more than autonomous driving. But we're going to get there, no doubt, one day. The fourth use case is, the fourth and fifth use case are fairly similar. It's around predictive maintenance and remote monitoring. So predictive maintenance is maintenance that monitors the performance and condition of equipment during normal operation to reduce the likelihood of failures. That is also known as a condition-based maintenance. Predictive maintenance has been utilized in the industrial world since the 1990s. Numbers that people are talking about is around 650 billion is lost worldwide on downtime every year. So AI and machine learning should leverage all the data, mostly time-based data, to make dents in that problem. Around remote monitoring, so remote patient monitoring is also something that is being very important and done in the healthcare space, and the last two are fairly well known, goes without telling, video surveillance and voice processing like Alexa or Google Assistant and others. And so if you look at the landscape now, the landscape we came up with is is based on the traditional IT infrastructure. So you had the edge on the low side. The edge was sending information to the cloud. The cloud was processing that information through the different technologies, data analytics, vision, NLP, and audio and audio analytics, and then the insights were sent to the application on top or to the edge as well. And so this is how we came up with the landscape at the time. We had about 66,000 jobs, 572 companies, about $30 billion of funding, and about 32 unicorns. This is the base of what Kailash is going to talk to you about in 10 minutes. You're going to see some difference, and Kailash is going to explain that difference. And then the trends that we have identified at the time, early in 2019, was AI is going everywhere. As we mentioned, this is the case. It's going from cloud to edge. Computer vision is the most permanent technologies, which is also a trend that is materialized. Autonomous machines are hot. I mean, it's everywhere. Autonomous vehicle, drones. You name it, last mile delivery. So a lot of development is being done there to deliver goods and package. A lot of activity and a lot of venture investment as well there. The trend 4 was rampant startup activity. Kailash is gonna talk about that as well, and then AI is driving new industry. So all those trends are trends that we think are validated for 2019. We still think that they are important, but what we're going to talk about now is even more important, and that's the main learnings that we've seen in 2019, which go way beyond everything that we've been talking about so far. And the first learning, it's something that is becoming more and more apparent, is the amount of data that is being created at the edge is massive. We're talking about 4 terabytes of data per day for car, 10 terabyte of data for wells, 5 petabytes of data per day for the weather, 2.5 terabytes per day for the plane, and 5 terabytes of data for wind farm. So massive amount of data are being generated in a context that means new requirements. So the first context is latency, and right now, if you look at everything around cloud infrastructure, we are getting a response of at least 0.5 milliseconds. So we are way beyond what is acceptable for latency applications. The bandwidth constraint cost doesn't, so the current networking infrastructure doesn't sustain the type of data that we've seen in terms of cost. So there is a huge amount of a huge requirement to control cost, and we are just working on a survey with our partner Twilio, and one of the main point is that cost is the major issue for the industry right now. So cost is, and by far, so cost is something that is important given the bandwidth constraints, and of course, as you've seen in the last 6 months, you're seeing increased pressure on the GAFA for privacy and compliance possibility and compliance requirements. And if the data is going from one place to the other, there is it's stored everywhere, and there is a major issue of data security. So if you're thinking about it, right, so massive amount of data is being created, requirements for application in real time or close to real time in IoT, the bandwidth constraints and the cost of implementation of those solutions means that processing and storage needs to come closer to the device. And so if you're thinking about the past, right, how was the data flow in the IoT world? The data was going from the autonomous thing to the network, and that was pure data, right? The data was aggregated in the cloud, and then being sent to the smart data layer to generate insights, and the insights were sent to the connected things, to the consumer apps, and to the enterprise apps. So that was kind of the architecture, the data architecture, and the way things were moving. And then insight would come back to the smart data for further analysis. So you had this level of data that were going from one layer to the other. Now, as you see, connected things and the smart network was at the lower level, and there are two things that are happening. The first one is now the edge and the device is going up, and the smart data layer is going down. And then the smart network is becoming an edge infrastructure. What we mean by that is it's not only a communication layer, but it's also a place where processing power and storage is going to be added as well. So the processing power and the storage is going to be within the network and not only uniquely placed in the cloud. There is going to be processing that is also going to happen at the edge. And so if you're looking now at how the data is going to be so let me kind of explain real quick. On the edge processing, this edge infrastructure, right? So it was a smart network before, and now we're adding computing power and storage power in that place. And so you're going to have the cloud, you're going to have this edge infrastructure, and then you're going to have the edge device. That could be a car where there could be also some storage and computing power, and then the edge sensor and chips where the data is being collected and originate. So this is a source of data from Win System and CB Insights. That way of looking at things is very focused on what we call the micro data center, because here you see like a lot of distributed data center, but there are a lot of other approaches that are competing that are led by many different industries. So for instance, the multi-access computing is something that is being driven by the telco. And depending who you ask, right, it's a network architecture that enables the placement of computational and storage resources within the radio access network to improve network efficiency and the delivery of content to end user. And so in order to do this, mobile edge computing adapt to the load on the radio link in order to improve the efficiency and decrease the need for long-distance backhauling. As network demands look set to increase significantly, mainly because of 5Gs and IoTs, mobile edge computing allows operators to deal with traffic and resource demands more intelligently, while also laying the foundation for more computing power and more storage power within the network itself. So those type of solution, of course, are linked to the Internet of Things, but are also linked to augmented realities and a lot of other applications. And that's kind of something that is gonna even being more more ask when 5G is created. The second one is more, it's something that come up from the Cisco and people in the networking company. And so it's called fog networking, and it's a term to use to describe a decentralized computing infrastructure, which both extend the cloud computing to the edge of the network, and you can place cloud, you can place data, compute, storage, and application in the most logical and efficient place between the cloud and the origin of the data. So you can basically place computing power, computing power and storage everywhere around the network, independently of each other, based on where you need to where they need to be placed. That's thinking led by Cisco. Then you have the notion of cloudlets. Cloudlets are a small-scale data center located at the edge of the network. So you get more to this notion of edge infrastructure. And then the next wave of technologies that you're looking into this is the micro data center. And the micro data centers are containers that are operated within the cloudlets. And the micro data centers is also something that is really taking advantage of the Kubernetes movement. And so, as you can see, you have telco companies, you have technology companies, you have CDN companies are all looking at this place and all coming up with technologies. It's a very confused space right now, and that's the reason why we are going to review the space at Edge Computing World. It's December 10 to 13, 2019 in Mountain View. So if you're interested to learn more about this entire area, you're more than invited to come to the event in December. So now let's look at the flow of data with edge at the center and the edge infrastructure to support this. The first one is the insights. So the insights now are created directly from the device, sent to the edge infrastructure, and the data are being sent to the consumer apps and the enterprise apps, and then the insight are gonna be sent back to the edge infrastructure and then back to the edge. So you have one layer of information that goes from the device to the apps through the edge infrastructure, and then the cloud and smart data are being used for anomaly. So an anomaly is being detected. This anomaly is being sent to the edge infrastructure that is going to be sent to the cloud, and the cloud is gonna send this information to the smart data layer, who is gonna create an update of the software. So that the update is now being updated, updating what's being run on the device itself and generate insights. So as you can see now, you have two different flow of data. You have the insights that goes from the device to the enterprise apps and the consumer apps, and then you have the anomaly that is processed in the cloud through the smart data layer. So if you're thinking about other consideration in that space, right? So the first consideration, and we've already touched on it, is where the data is going to be stored. Is the data going to be stored directly in the cloud, in the smart data layer, or if the data is going to be stored on the device or somewhere on premise? You have companies like Exnor that are advocating for this notion of a digital twin. So within Within the smart data layer, you have a digital representation of the device or of the machine that is being operating, and as part of this representation, the system is also going to understand where the data for specific information is being stored. And so when the smart data has to do some type of work, it's going to call on the information that is being stored somewhere, brings that information together, process the information, and then destroy the information in the cloud, keep the insight or the anomaly or the updates, and then send the updates back. So the idea and the trends are to create this notion of a digital twin, either store all the data in the cloud with a digital twin, or store the data somewhere around the edge infrastructure or on the device itself, and then call that data upon, and then use the digital twins as a way to update and do predictive maintenance, do telemetry, do all the things that needs to get done, and provide the updates that are needed for the firmware for the thing to occur. The other thing that you need to think about when you're thinking about those type of application is the edge economics. Given the fact that there are going to be a lot of devices that are going to operate those applications, the economics is going to be a little bit different. You need to think more about, if you're thinking about building applications for this, you need to think more about how mobile applications are being paid and developed rather than cloud application. So the edge economics is going to be different. As part of the conference, we are gonna talk a lot about that. We have a couple of days linked to the business models as part of our Edge Computing World Conference. And then the last thing that needs also to occur is cheaper, smaller, and more efficient hardware at the edge. We are on our way to do that. There is a lot of things happening, but also it's not completely there yet. It's actually one of the blocker, right? And so if you're looking at the blocker for AI at the edge, the first one is a high R&D cost. All the development that need to be built around the edge at the device layer everywhere. So there is a high R&D cost. There is also a lack of talent that needs to, so even more than for AI in particular. And then, as I mentioned, the technology development curve, we're still very early in terms of the development of the compute capability and the storage capability at the edge, and we need more work, more progress to be made. So because of that, even those AI for IoT is going to be pretty big in the next coming 5 years. The growth is not going to be as big than for the entire AI industry. So, if before getting into the landscape and the taxonomy, if I want to leave you with like 3 things that you need to think about. The first one is the edge is becoming the center. So when you're thinking about building an edge, an IoT implementation, you need to start with the device and the premise itself first, and then think about the cloud as just a way for you to process data. You need to think about the way to organize information with this new notion of digital twin. So beware of this emerging notion of a digital twin, which is a physical representation of the device and the machine itself. And then the last thing is you need to be patient because infrastructure is still not completely there yet, and so we are very early. But I truly believe, and we truly believe at Readwrite Lab, that this revolution is going to be far bigger than cloud and anything that we've seen so far. Questions. Let's move to the taxonomy. So Kailash, do you want to go ahead?
Yes, I see we have a few questions, but we'll probably save them to the end.
Okay.
Let's now talk about the blueprint of the landscape itself and see how we thought about building the landscape. So can you go to the next slide? Next slide. So here's the blueprint of the edge landscape, right? If you look at the landscape, it has two main components, the horizontal and the vertical components. The horizontal component is the infrastructure that's required to run AI applications. And the vertical components are the industry solutions or use cases that are built on top of them. So a simple way to look at it is the edge, smart cloud, smart data, and application management all provide the infrastructure on which industry-specific applications can be built around, let's say, security, AVs, consumer, and industrial. So let's start off with the edge, right? So the edge consists of chipsets and platforms, and this is where the AI processing is happening. These chipsets need to be designed with having a low power consumption, given that they'll be deployed in edge locations, and they would also it's a very fragmented market given the variety of use cases in these deployments. It could be deployed in a smart speaker in a home setting, or it could be deployed in a smart camera in an industrial setting. So the players here manufacture in the millions and focus on different applications. The smart cloud provides the connectivity to the edge, and it's mainly dominated by bigger companies, which are well funded, the IBMs, Amazons of the world. When you're building servers and compute infrastructure specific to AI, it has different requirements. So the NVIDIA state-of-the-art server, for example, provides 5 petaflops of compute, and has a much bigger form factor and consumes a lot more power than regular servers. Another infrastructure piece where we see a lot of startups is in the smart data space, and this is dominated by high number of companies and startups. This is mainly because the barrier to entry is much lower given the pure software play in this space. The application management is a new segment that we have added, which is mainly focused on deploying and managing software updates to the edge devices. I'll go into more details in the following slide. On top of these, you have several applications, security, autonomous vehicles, consumer, and industrial. We'll look at a couple of new segments that have been added into each of these, but this kind of is the blueprint that we're going with. Next slide. So let's now look at the new segment that we have added, which is the application management. Next slide. So according to Technovio, the global application management services market is expected to reach 105 billion by 2021, and it's growing at 4.75% from 2016, right? And this is a huge growth. Now, if you think at the heart of application management is the application itself, and so when you're building enterprise applications today, it's fundamentally different than it was even 3 years ago. While the move to the cloud was the first wave of transformations that managers had to go through, the edge as mentioned by Philippe earlier, flips the IT infrastructure or architecture on its head, right? And Gartner, for example, predicts that 75% of data processing is going to be outside centralized cloud or data centers by 2025. Currently, that number is 10%. So there is a need here that companies must look beyond established practices to really accelerate the pace of translating business needs to application opportunities. And so let's look at the next segment, which is the OTA, and OTA means stands for over the air updates, and the over the air updates is fundamental in staying relevant in the AI or IoT space. So what is over the air? So OTA refers to various methods of distributing new software, configuration files, and even updating encryption keys to devices. Back in so the next slide. So back in 2016, Ford actually mailed pen drives with software updates to its users. The industry has come a long way from this. Apart from the customer experience of updating software manually, there are several security issues with this approach. And you're seeing the Teslas of the world really excelling and building new business models by offering software defined features to their cars. There was a research done by J.D. Powers which found that 189 distinct software recalls were issued over the last 5 years, and these affected over 13 million vehicles. So think about the business challenges of bringing the car to a service center and then fixing these issues. Right. So what's more surprising is out of the 189 software recalls, 141 actually increased the risk of a crash. So this really brings front the prominence and importance of the OTA infrastructure. The question now is, who's going to really own the OTA? Is there going to be a marketplace in a car context? There are mission critical updates as well as non-mission critical updates. So anything that's to do with drive control are all mission critical, and then the infotainment and other settings are non-mission critical. So how are these softwares going to be updated? How are dependencies going to be managed within between the different ECUs that are present within the car? So these are really interesting questions that are being answered, and different companies are leading in answering them. So next slide. So the next part of the landscape was the smart data segment, right? Here, next slide. As mentioned earlier by Philippe, AI is distributed. So AI is being processed at the edge. Insights are generated from the edge to the consumer and enterprise apps, and then anomalies are being processed in the cloud with the analytics layer. So with this, what's really happened was the emergence of the digital twin concept. Now, here, the digital twin term was coined back in 2002 by Michael Greaves, and it's basically a complete digital replica of a physical object, and the twin is basically the main point of communication in the digital world. So you have more OEMs now providing a digital twin of their sensor, for example, and the main advantage of building this digital twin is you can preempt failures. You can also generate a lot more insights, and you can run several cases to optimize efficiency before really trying it out in the real world. So let's take a smart factory, for example. So a smart factory uses the concept of a digital twin not only to model individual sensors, but they can also model subsystem and the whole factory as such. So what's also interesting is you can also analyze how people interact with systems and model that into the digital world. And this way, you're really going to be able to improve your performance. In the automotive space, for example, you can use digital twin concepts and apply things like your preferred seat settings or temperature that you prefer from one car to another car. And one of the concepts, or one of the most driving developments in the space, which have forced which have kind of pushed AI development is the emergence of deep learning platforms. So next slide. So deep learning platforms have really accelerated the development of AI field as such, and deep learning is a subset of machine learning. And so next slide. And the algorithms really help businesses make better decisions. Some frameworks here are, the popular TensorFlow, PyTorch, Microsoft Cognitive Toolkit. TensorFlow is by far one of the most popular deep learning platforms. It was developed by Google. And if you look at the GitHub activity, it has a very strong developer community. PyTorch was created by Facebook. You see a lot of research papers and researchers using PyTorch. And then the Microsoft Cognitive Toolkit is, so the Skype, Xbox, Cortana all leverage this framework. It's mainly focused on speech and vision. So now let's look at predictive maintenance, right? If you think of predictive maintenance, next slide. If you think of predictive maintenance, there are 5 basic categories of predictive maintenance. So you have the classification problem. So this is around which device will fail, right? So let's look at how beer is. So let's look at the beer brewing process. In the beer brewing process, there is a filter that needs to be replaced. And once the filter goes bad, the color and the taste of beer is not good enough. Currently, there's a taste master who is in charge of replacing or telling you when the filter is likely to fail. Using the classification problem is you can tell which device will fail. So using predictive maintenance, you can replace filters on an optimal time, and this is going to save companies billions of dollars. The second is the regression scenario. And here it's about predicting what is the remaining life of a device, for example. So when is a battery going to fail? In terms of an oil rig, when are sensors in the oil rig going to fail? So the carbon monoxide sensor is a key one here, and so identifying when it fails or how much life is remaining is going to be important, and that's the regression scenario. The third scenario you have is the optimization scenario. And here you're using machine learning algorithms to actually make a decision to optimize a specific variable. So let's take, in case of the home context, you have, let's say, saving energy. So you could optimize for reducing your energy consumption of the home, and the ML models can tell you when to perform certain actions like switching on the washing machine based on the electrical charges for different times. You then have identifying anomalies, patterns, and benchmarks. So here it's about learning from all existing data that we have about, let's say, in the airline industry, the landing data. You can then predict positive and negative cases. You can look at what is a good landing, what's a bad landing, and what constitutes a bad landing. So let's say the flight path is one of those variables. You can then go back to the flight path and say, hey, this particular flight path has a higher probability of having a bad landing. And then the most interesting one, which was discussed at Google I/O, is the virtual sensor concept. And here it's important for certain sensors that even in the absence of these sensors, you have the readings. Let's take the water gauge, for example, right? So the water gauge, in terms of a flood, if the water gauge is broken, you need to know what the water flow conditions are. You cannot really predict, and you can't really predict when these are going to fail. And so even when they fail, you're not going to be able to send a workforce or a person to replace it. But at the same time, it's highly important that you get the readings of the water flow. So here you can use machine learning models to really predict when to stop or what the flow is, even when the sensor fails. So next slide. And this is the final landscape, the AI for IoT landscape. All right, so we have, so as part of this update, we have added 43 companies or products, and these have created over 15,000 jobs. And the companies have raised over $5.7 billion, and there have been 3 unicorns that have been added. These are Uptake, Nauto, and Ninebot. And as we track more companies and more segments, we are seeing the significant impact this industry is having. Let's look at some of the M&A activities. Drive being acquired by Apple was one of the recent acquisitions. And so here, Drive was, going out of business and was on the verge of closure. Apple's acquisition gives them, the self-driving technologies that Drive has, but also, is a step that they've taken to recruit the right talent in the space. Eloquent is a conversational AI startup that was acquired by Square. So they're basically using AI at the edge, and Square is planning to use these to really empower their merchants to reach customers. And finally, we have Deep Science, which was acquired by Defendry. This is one of the key use cases of AI at the edge. So Deep Science develops an algorithm that really looks at people who are carrying concealed weapons or intruders based on CCTV footage. Now, Defendry has acquired them and has integrated this technology into their offering to really prevent armed robbery. So what's next? There are more needs at the edge than IoT. AI for IoT is going to evolve to AI for edge, and we are going to continue to identify different use cases and companies and track this market. So we have, so finally we have the Q&A section.
Yeah, so Q&A, right? So first question was, and you mentioned that AI will be performed both in the cloud as well on premise at the enterprise. What do you think the split will be between cloud and on premise? Will it be something like 80-20? So few thoughts. One is that it depends if you look at all the applications that have been developed between, or if you're looking at the newest one, if you're looking at all the applications that have been developed right now, a lot of those applications are on premise and not as many are on the cloud. So I would say it's probably reverse, probably 80 premise and 20 cloud. But right now, if you look at the new applications, I think it depends on it depends on two things. It depends on whether you're an end user or an IoT solution provider. So that's one thing. So if you're an end user, you're going to probably do a little bit more on premise than if you're an IoT solution provider. And then the second dimension is the industry you're in. So for industrial internet, for instance, a lot of the work is going to be done on premise, and whereas for other like consumer X, a lot of the application is going to be done in the cloud. So you really have to look at two different variables. One is the industry, and the other is whether you're building your solution for yourself or for somebody else. Then Ramon is asking about what is the vertical with highest revenue for IoT. So it's an interesting question. We have a Twilio, we have a survey we're doing with Twilio right now, and we've gathered about 1,000 responses. And again, it's not a completely easy answer. I would say right now the people with the most deployment are consumer internet, but they are not the one with the most revenue. The one that are with the most revenue, believe it or not, are oil and gas and agtech. Those are the two verticals where you're seeing more implementation and more budget for those implementations. Note that they are also the most advanced in terms of implementation, and so because of the fact that they are the most advanced in terms of the implementation, there are more revenue being spent. So that's kind of on the number of implementation, the place where there is a lot of activity in addition to IoT is manufacturing. So manufacturing is a little bit less advanced than oil and gas and agtech, and but you're seeing a lot of premise there, and they are spending and we don't know if they are spending less because they are less advanced, or if they are spending less because they are going to spend less. So more to come a little bit later. How will the cloud operators offer AI? Will it be IaaS, PaaS, SaaS, and why? Good question, and difficult to answer that question. It's gonna depend on who is offering the solution and why. So Amazon is offering the solution in a certain way. Microsoft in a very different ways. It's difficult for me to say which one is IaaS, PaaS, or SaaS. But we're gonna go back. We're gonna come back to you and the group with a better, more informed answer. Is data generated at the edge? So that's Gaurav Makar is asking: is data generated at the edge? And which help train AI model ever deleted? Would there be compliance requirement to keep that data around forever? Will that data need to be moved over to the edge for archival? All those questions are very good questions, Gaurav, and will depend on where you are. For instance, for GDPR purposes, it would seem that the data need to be deleted at some point. But for compliance purposes, for other like HIPAA compliance, it's gonna be, we may want to keep the data forever. The storage is also gonna depend around, the compliance issue and what you need to get done. So I would, right now, the notion of forever doesn't exist. And so there is a case for buildings that's forever, features in most of the applications, so that we know that the data doesn't exist anymore. But and then in terms of where is the data going to be moved? Yeah, over to the edge for archival. Yes, the answer is yes. There is. Archival is going to be done probably somewhere outside the edge, because a lot of the edge is around low footprint for low footprint compute power, low footprint storage power. So now the question is, where is it going to be archived? Is it going to be archived closer to the cloud, or if it's going to be archived closer to the edge? Good question to be answered. Who is going to deploy and own the edge architecture, i.e. micro DC? That's a Gordon Wigan question. Will it be the carriers? It's going to be a combination. It's going to be the carriers. It could be the smart cities. In the case of industrial internet, it's going to be the companies themselves. It could be the CDN developers like Iconize. sky is the limit of who could be providing those type of solutions. Smart cities could be providing also some type of solution like this one for the data that they own. It's going to be the automotive companies are going to be probably providing that edge infrastructure for the cars that they're operating, and there are going to be a need for communication between the OEM automotive platform and the smart city platforms. Just for the car to be connected, to be talking to the traffic lights, for instance. So all of that is gonna be work out, and I would think that you're gonna see a lot of players, even industrial companies, becoming a provider of those type of edge infrastructure for their supply chain or for their customers. So yes, for the carriers for sure. Yes, for the cloud provider for sure. And then emerging companies, emerging providers are going to be, as I said, OEM, smart cities, and the like. Over time, you're going to see a lot of players there. And again, same thing. If you want to learn more about this December conference, we're going to talk at length about where people are and how they're planning of developing those type of services. Could you please, so that's Kumura Podari, could you please share your perspective on who hosts, own, operate a typical cloudlet? So I think we've answered that question. So telco, enterprise, or cloud service providers are all gonna be players in that space, and CDNs as well, like Akamai. Would you expect smart data to be pushed down to the edge rather than moving all the data over the WAN? Absolutely. So you're going to see this is a major trend, and it's not going to stop. And eventually, would AI model training be done down at the edge? That's an interesting question. I don't think so, because you need aggregation over many edges to be able to create those models. So maybe for factories, when you have enough critical mass to do those type of models, there is also an issue. There are also an issue of security and compliance that could get into the consideration here. But I would expect the AI model training to be done at the cloud, because this is the place where you have what you need in order to in terms of aggregation of data. Then I have an anonymous attendee that is talking about cloud AI system are developing, enterprise users having to take the role of vendor at the forefront of deciding which services to use. Is there some push for a consolidated open architecture for the software and hardware development? The answer is yes. It's always the holy grail to have those type of solution. Is it going to happen in the short term? I don't know. Kubernetes is kind of the one answer to those type of questions, but it's not completely. And it's 10:06. Kailash is telling me it's 10:06. So thank you very much for Vivek and Mike. I'll answer your question directly. So thank you so much for having spent the time. Do we have a webinar next week, Kailash?
No, the next webinar is going to be on the 25th. It's the Connected Car webinar that we're going to be presenting.
Yes, and so if you want to talk more about AI for IoT and what's happening at the edge, the Connected Car webinar is a nice follow-up, and it's in 2 weeks. So see you in 2 weeks at 9 a.m. On Thursday. Take care, and thank you so much.
Yes, thank you all. Have a great day.